Let's consider a vector lying on a plane. So this is our vector v. Now we can write this vector as the sum of two other vectors. And in general, they will be chosen as perpendicular to each other. To see how we can do that, let's just choose two axes. One in the horizontal direction, let's call that the x-axis, and one in the vertical direction, let's call that the y-axis. And then from the tip of this vector, I will draw perpendicular lines to the horizontal axis and also to the vertical axis. So now I can define two new vectors. One will be starting from the tail, the origin or the tail of the vector v, to this point on the horizontal axis. This vector I will call vx. And the other one, the second vector, I will start from again the tail and go up to this point. This is vy. So from the parallelogram method of adding vectors, we see that the vector v can be actually written as vx and vy, the sum of these two vectors. And this vx and vy are called the vector components of this vector v. And of course, if you change the coordinate axis, x and y axis, the vector components can be different. But still, at the end of the day, the vector v will be the same independent of how you choose your axis. Now, another thing to pay attention to is we will also call the magnitudes of these two vectors, vx and vy. Well, these are, strictly speaking, these are not really the magnitudes of vx and vy because they also carry the sign. So just imagine this one-dimensional axis. So this vector vx will be positive if it is pointing in the positive x direction and negative if it's pointing in the negative x direction. So these vx and vy, which are the magnitudes of these vectors with their corresponding signs, these are called the scalar components. Whereas these are the vector components. So depending on your axis, the vector and scalar components might be different, but still the vector itself will always be the same independent of your component, of your axis.